Okay, 9.1. So we're going to be solving for f of x equals to f prime x. So f prime x, when you apply the laws of derivatives, you're gonna get 9x squared, right? If you equate this with f of x, it's going to be 3x cubed equals to 9x squared. So now don't get tempted to divide by x squared on both sides. The best thing to do is to take 9x squared to the other side, because if you divide by x squared, you are basically losing a solution. So here we have a common factor of 3x squared, x minus 3 equals to 0, 3x squared equals to 0, or x minus 3 equals to 0. Therefore, x equals to 0, or x equals to 3, right? And then we continue. So we are given the graphs of f. So f of x is 3x to the power of 3. F prime x is 9x squared. And f prime x is just going to be the derivative of this, going to be 18x. So if you sketch these graphs like a rough sketch, so you know how the basic cubic function is something like this. It won't differ that much from 3x cubed because you're multiplying it only by 3, right? So it's gonna be the same graph, just that it's going to be a bit different. And then 9x squared is like the x squared graph, but they multiplied everything by like 9, but it's still gonna be relatively this shape. And the graph of 18x is just gonna be a graph which is going to pass through 0 and 0 like this, a straight line, right? So what you're gonna do is that 9.2.1, it says for which of the graphs will, so let me just label them. This is f prime prime, and this is f. This is f, and this is f prime, right? So 9.21, for which of the graphs will 0, 0 be a stationary point? So 0, 0 is here. But then you have to define what is a stationary point. So when we say a stationary point, we are saying where the gradient equals to 0, or the derivative at that point equals to 0. And where can we see a stationary point? At a point of inflection. So what is a point of inflection? So you see in the cubic function of x cubed, this point over here, where the cubic function changes concavity. So that's called a point of inflection. So you know how like the cubic function does not necessarily doesn't have it does it doesn't have it doesn't have it doesn't have a turning point. And then so we can also see it where in turning points. So turning points is where the graph turns. For example, in the graph like this, the graph turns like that's the turning point. So now here they are saying for which of the graphs will 0, 0 be a stationary point? That means that of those three graphs, for the graphs f and f prime, because f is this graph, right? This graph, and it has a point of inflection at 0 and 0, right? And then we see that f prime here is this graph, and it has a turning point here at 0 and 0. So you're gonna say f and f prime. 9.2.2 says explain the difference, if any, in the stationary points referred to in 9.2.1. So yes, the difference in the stationary points is that for f, stationary point is a point of inflection, right? And then For f prime, stationary point is what? Is a turning point. Yes.